Hey guys, Mr. Rysz here. So I'm going to walk you through the first part. So activity 1.1.1, did I say that right? Part one, just to show you guys how we can go through. So a lot of this you could have probably done on your own, but if you want a video walkthrough, I will make them, and that's my goal. Okay, so I'm just going to click preview here to go through this. So we're looking at algorithms, and that's what we want to know. So an algorithm, the instructions that you followed in the previous sections are examples of algorithms. An algorithm is an ordered set of clearly defined instructions used to accomplish a specific task. Okay, I guess we talked about the trifle here, but we didn't do it. So what was the purpose of that one there? Was to just make sure the task was reproduced with the same drawing every single time. So the expression of any task as a sequence of detailed steps is an algorithm, okay? So as long as we have steps in order of what to do, that's an algorithm. Whether it's instructions on how to fold a shirt, how to parallel park, solve a mathematical problem, algorithms are used everywhere. So we have some notes here. With an algorithm can be represented in multiple ways, most of which we'll use in course. All right, so this is step 6, that's what the 6 stands for. Or explore the most common ways to represent an algorithm. So first thing we could be like when we troubleshoot a TV with cable issues, okay? When you check the TV source selected, then you check the back of the TV, check the imports. And then if the cable box isn't plugged into the TV, you plug it into one of the imports. And you make sure the TV source selected the matches with the import selected used for the cable box. The TV still doesn't work, you call customer source. So you go through your steps of how to solve a problem. You think about it too, like anything you're not working. Think about games that you play, you know, how to solve them. You just usually follow a pattern. Okay, so natural language. The first method is natural language, which is an ordered list and steps expressed in the natural language, so English, Spanish, English. So right here is a natural language algorithm, okay? Next, we got this example here. So this is how we troubleshoot a TV, but it's set up. That's called a flow chart. The second method is a flow chart where the diagram shows the sequence of steps using standardized steps, such as rectangles to represent actions, rhombus to represent directions or decisions, and arrows to show the flow of the pattern. So when we get to, if we got a problem, is the TV working? Yes, well, we watch it. And so we follow those steps and we move on. All right, next is pseudocode. So the third method, pseudocode, is a written set of instructions that follow a certain structure. It looks more like code, but cannot be executed by a computer. We'll learn more about pseudocode later on in this unit. And pseudocode kind of goes by different names too. We can embed pseudocode, and that's just something that we will use. So we're just kind of writing up code here using the indentation. So we check to see if TV, okay. Check box if cable isn't plugged. So if that's true, then we'll do this. No, then we'll do that. So we embed our instructions. And then the fourth is the programming language. So the fourth method is a programming language such as Python, Java, C++, JavaScript, etc. Example here is all in Python. Programming language is a structured set of instructions with specific keywords and formatting that can be interpreted and executed by a computer or digital device. In this course, you will primarily learn the program using Python programming language. We will cover other ones. Clarity and readability are important considerations when expressing algorithm. Now, one thing they talked about pseudocode, we do kind of call this like hashtagged out part of the code, pseudocode. Works well that way. Algorithmic thinking. So algorithmic thinking is the process of solving steps by identifying tasks required to solve the problem using algorithms to clearly describe each task. Algorithmic thinking is an acquired skill that takes practice and repetition and is used in many disciplines. In this lesson, you will be writing algorithms as part of the planning stage and converting them to Python code to produce artistic creations. So we got our first question here that we'll answer. We're going to match the descriptions below. So instructions that look structured but are not understood by a computer. That is pseudocode. A diagram that shows the flow chart of an algorithm. Or flow of the algorithm. Well, that's a flow chart. Well-structured, here we go. Start over, Riz. Here we go. Well-structured instructions that can be understood and executed by a computer. It's a programming language. Instructions that are expressed using spoken language, English or Spanish as natural language. Okay, next we have an embedded program, and hopefully you have already signed up to Ripple and it will work. So you can see this in two different ways. Oh, I'm screen sharing. All right, in this section, you use Python programming language to have fun with some shapes and colors. Like most programming languages, Python offers a comprehensive list of predefined reusable code called modules. Each one of these functions provides clarity and provides function around specific programming needs. You will use the turtle module to move an object on the screen and create careful drawings. So some of the Python code below is an interface called a code editor. The code editor allows the program to run. So some of this code here, now I probably could change the screen size, but I want you guys to kind of open these things and see what it looks like. Now, one thing you might notice is when you open it, it's saved under mine. And then if you edit it at all, it should make a new version of yours. Actually, you know what? I'm probably logged into here, so I'm going to try to do something else. Let's see if I can open this in an incognito window. There we go. So now if I edit it at all, yeah, now we make a different version. So that's what you guys should see. It should, once you make an edit, it will change to yours. So if I run this, what happens? That was nice and slow. Sometimes when you run these things, it goes super quick, but we have code that says import turtle as turtle, painter equals turtle.turtle, painter.forward 100, painter.right 90, wn equals turtle.screen, wn.main loop. Okay. So we saw what happened. We'll run it again. And that went even quicker, but let's go through. In fact, I'm not sure if you even saw that. I'm just realizing this now. I probably don't have my screen share on. No, I think you guys saw that. Okay, I'm going to minimize that. Go here. Okay, so when you run the program, you execute it in the code at a line at a time, starting at the top. In a few steps, you'll learn what the code does. So from now, you can run the program, see what it does. We viewed the results and we can see, and we kind of just talked over right there. Let's move on to step 8 here. The turtle object can be hard to see in the code editor. Add the following line of code to line 4 and then change the size of the turtle. Okay, so we're going to add this line of code here to line 4. Go back to that screen here, line 4. I'm just going to paste it in there. I'm going to run it again. Ooh, it has no turtle set. That's funny. Maybe I'll have to edit it. Is it size 3? Interesting. Did I type anything wrong? No. I guess I will have to change it. Let me pause this video and see if I can figure out this mistake real quick. Okay, so reading through this, the Ripple that we are using doesn't allow you to change the size, so that's something we won't be able to do. So we'll just answer the questions as they are. Okay, so next we'll run through the program. How would you describe the turtle's behavior? We looked at it. It traveled east 100 pixels, then turned right. Okay. All right, guys, so the next question here, part 11 here. So if we take a closer look at the code, notice how the first line of code imports turtle as TRTL. This imports the turtle module to allow us to use its drawing functionality in the code. So if we look at the next line of code, what do you think painter equals turtle.turtle does? So if we look back at this, what this does, if you don't know, if we run it, we can see, actually makes a turtle on the screen, and we call that turtle painter. So makes a turtle icon on the screen and calls or names it painter. All right, the center of the screen turtle is at the XY coordinates 0, 0. What do you suppose are the XY coordinates of the turtle object when it's first created? Well, if we go back and look at this, we'll run it again. If the center of the screen is at 0, 0, that turtle starts at 0, 0. Now it ends up moving over to 100 pixels, but it starts at 0, 0. All right, so turtle, it's important to understand the difference between the turtle module and the actual turtle object. So the turtle module is a Python file that has predefined reusable code. You can import it and use it in any drawing functionality. The turtle object itself, in this case, the one that we call painter, is an actual turtle that you can manipulate on the screen. So what do you think the code painter.right90 does? All right, that would actually make the painter turtle turn right 90 degrees. Now 90 pixels is not a turn, pixels is a distance, 90 degrees is. So the one thing that we look at the end of the code here to describe the screen is where in which the turtle graphic resides on the object. So the line of the code wn equals turtle.screen saves the turtle screen object called wn, and giving the program a way to control the screen level behavior when we close the turtle screen. So finally, the wn.main loop is used to keep the turtle screen from exiting once the program is complete. So it just doesn't go away once we finish the program, it will stay up there. This way the screen will persist throughout. So one thing that's kind of nice is Ripple already has that kind of pre-built in, but it's not a bad thing to always do in case you want to transmit this code from Ripple to like Tinker or anything like that, just to use those always at the end. So hopefully you guys can submit that quiz and you have a good score, and I'll make another video to help you guys with the next part.